So we were looking at this whole our micro satellites and using them with a manufacturing materials process. We've been working with Michael on building one for LiftPort, and we thought, well, maybe there's something that we can do that would really make this kick over. And so we've invented a micro manufacturing satellite that is probably the smallest that has ever been built, that is, fully functional. So if we can go to the next slide, this is what Aurora is. We've talked about Aurora before on here. This is the satellite base that we use. And to put the size of this in context, well, you can see it's next to a Coke can there. This is a very, very small satellite. Okay. I didn't have regular Coke. I don't know why I had a Diet Coke in the fridge, probably because I don't drink it, and it's been sitting there for a while, so it made a great prop. But that gives you an idea of the scale that we're talking about here.
Well, it never ages. So.
Well, that's true. So, okay. Well, this is now what we call the Aurora Material Science Lab. And it is a 90 millimeter by 70 millimeter by 50 millimeter space designed specifically for doing material science. Again, using that Coke can as a reference, we've got a little box there around what this thing actually is. That's how tiny it is. It's very, very tiny. But with it, we're able to do it's a standardized spacecraft. The architecture and configuration are all standard. All the mechanical, electrical, thermal, all that fun stuff, we take care of that. You don't have to worry about that. As a payload, you just have to worry about what goes in your little box. And then your box connects to our bigger box, and then we launch the bigger box, and then we send back your data. So you can do all kinds of fun things, integrated experiments. You can do sensing tests. If you're doing materials tests, you can have cameras and temperature sensors all around what you're working on. So we can do a complete monitoring of what's happening. And, it's completely autonomous. Once you program it, it does what it needs to do. If you want to communicate with it, we have a dashboard, we have APIs, tie it right into your own back end. Your science in space going straight to your systems. That's the plan. So it's like you build the box, you give it to us, and the next thing you know, we launch it, you're getting data, and you can go about your experiments and working with your materials. So, yeah, that's what we're trying to build. And some of the areas we're looking at, if we can go to the next slide, I know this is not exactly easy. Thank you for doing all of this. Okay. So let's say you need some materials and you need to test how long they're going to survive in space. Wink, wink, nudge, nudge. They're on the LiftPort side. We're doing a durability test for them. And so what are the radiation effects on your materials? What does atomic oxygen do? Does the vacuum of space actually damage what you're working on? Okay. The idea is to build a satellite with this payload inside it, and you can do a long duration experiment and get the information you need. This is very different from what the shuttle did back in the day. Remember, they had that big, huge lab. They launched it into space. They were going to retrieve it a year later. And a little accident happened in between, and it was several years before they got it back. Well, the way we do it is it doesn't matter for retrieval. Right? We're sending you the information in real time as we're going around the planet. Because of the way we build this, and again, the 3D printer has been very helpful in this regard, thank you, we can build a space self-contained that can allow you to do things like testing, welding, or in-space manufacturing. You want to do a robotic assembly, you can put it inside there and you can actually make it work. So it's extreme miniaturization for the support, and here's a box. Go have fun. That's what we like to say. All right, next slide, please. Okay. So what else can you do? How about some functional materials testing? All right, this kind of draws back to that whole atomic oxygen, long duration. But There are things like, do you want to test batteries? Do you want to test solar cells? Do you have a semiconductor you want to try in space? Do you have a new microprocessor that you want to give a workout to, and you want to put it in the real environment? Simulated environments are great, but simulations only go so far. You got to put the stuff in space eventually. So here, let's put it in space. Let's test it out. And also, finally, we can do bioengineering in life sciences. You can't get the materials back. Okay, so this is running again remote experiments that allow you to look at reactions or life sciences tests that you don't want to do here on Earth. Organelles is one that I've heard thrown about a lot. We could you could actually assemble a miniature liver or kidney inside this capsule and test how it grows in the microgravity environment in low Earth orbit. So that's some of the things that you can do in this little tiny space. So, yeah. Next slide.